Hello, welcome to the Statistical Software Toolkit. This is a special topics talk on behalf of the Biostatistics, Epidemiology, and Research Design Core of the DaCCoTA project at the University of North Dakota. I'm Dr. Mark Williamson, and today I'll be counting down what I would consider the top 5 statistical softwares for statistical analysis. So for every researcher, after they've generated data, say through an experiment, observational study, etc., they'll need to analyze their data. So there's a lot of options to do so. Just like an actual toolkit with tools, our statistical software toolkit has many items to select from. And some are better at some things than others. Just like in real life, you might use a hammer for one project and a wrench for another. Really, at the end of the day, all the statistical software are tools to aid you in your research. Some are better than others, some are worse, but they're all useful. And as a researcher, if you've already selected a tool you use, this talk might still be helpful because it's good to know you have multiple tools. You never know when you'll need to do analysis where a particular software program has just the right features. So here we'll be counting down the top 5 tools for statistical software. So now let's get some inclusion criteria out of the way here. For the software to be considered on my list today, it needs to be free, have a free version, or have a version that can be accessed through UND for free. UND has a variety of statistical software licenses that can be accessed by faculty, staff, and students at UND. And then the other inclusion criteria is the software has to be something I've at least had some experience with. I am by no means an expert in any or all software packages. So, without further ado, let's get started. Number 5, Stata. Stata is a general purpose package created by Stata Corp in 1985, and the tool I would consider this to be in your toolkit is the ratchet wrench, because it has 2 different ends. Ratchet wrenches have the more manual end, you have to do more work on your end, and the ratcheting end, which is typically easy and more automatic. Just like the ratchet wrench, Stata has both a more manual option and a more automatic option. So to access Stata, you'll need the Citrix workspace from UND. You can follow this link here if you don't already have Citrix. When you have the app loaded and open, this is what it looks like. If you don't have any icons for your first time, you'll need to go over, add different apps, and you can add Stata 64 from there. And when you boot up Stata, it looks like this. So to be honest, when I first opened up Stata, it kind of looked like graphical text adventure that you had to get your way through. And as I learned, there's a portion of Stata that is almost exactly like that. So some great features of Stata. Here, I just have a video here. There's a command line, so you can actually type in your own commands. There's a whole language, but then there's also a pull-down menu with you can do charts, analyses, all these sort of drop-down menus like classical tests of hypothesis tests. You can do generalized linear mixed models, standard structural equation modeling, so kind of the whole works. So really there's this the back and forth between, you can use the command line for essentially coding yourself, or you can use the pull-down menus. And then it turns out you can also use user-written programs that has functionality for that as well. So some of the downsides to Stata is because it has a lot of these pull down, I would say it has what I call the plug and chug problem, which is it's very easy to like just pull down and run things in it without really understanding it. You're plugging and chugging without understanding the underlying processes. So it's easy to get things wrong because you don't know what you're doing, because computers are very fast but also very dumb. So you need to do exactly what they'll only do exactly what you tell them. And if you tell them something wrong, they'll pull out something wrong. So you could do analyses that have gobbledygook for the endpoint because you entered in gobbledygook up front. So another downside on the other end of things, if you use the command line to code yourself, is that of course there's a code learning problem. It has its own, Stata has its own kind of language. So you actually have to learn that, and so it obviously has a slower learning curve than like using the pull down menus. But by and large, Stata is a very, very nice software. I'm excited. I know the least about it of the ones I'm using here, so I'm actually excited to work a little more in it and see exactly what it can do. I would say to suggest for you to use it is it's really an all-purpose data thing. It can go very basic stuff to very complicated analyses. Number 4. SPSS. SPSS is an interactive statistical analysis package created by SPS Inc. and then acquired by IBM in 2009. And I would consider this the power drill in your toolkit. It's pretty easy to use, got a lot of functionality, and it doesn't take a lot of effort to get going right away. So SPSS can also be accessed through the Citrix app. So here it is right there. And if you pull it up, here is the landing page and a blank data set. If you open up empty data set. So some of the features, this is going to be almost all pull down bars, as opposed to Stata, which had coding or pull down menus. If you see here, this kind of looks like a spreadsheet because it is. So you can actually, within the package, you can edit and create data or load in data. So that's kind of nice to be able to really manipulate it and tweak it. And it also has a lot of sample data sets. Now, some of the downsides is I found that sometimes it's kind of a pain to get data in. And again, it has that plug and chug problem. I know SPSS is used a lot in like the social sciences or psychology. So if you don't have a lot of background in SPSS, it's easy to just do a lot of stuff with the pull down menus without understanding what's going on. And whether or not this is a downside on your end, there's really no coding. So if you can't figure out how to do it in a pull down, it can be very hard to get things done. But, maybe it's the no coding is not a downside for you if you just would not rather do any of that kind of higher end coding. So here is an example of like a data set. You see it's all loaded in. It's kind of nice that it has two different views. This is the data view, which kind of looks like a normal spreadsheet, but you can also switch over to variable view, which kind of has all the information on the variables, which you can set, especially like you can set values, what their values mean, your measures, like whether it's nominal, ordinal, or scale. So there's all those things there. And then going back to their view, so you can transform your data, which is really nice. You can, all sorts of analyses from descriptive studies, Bayesian GLMMs, survival analysis. And then there's also Amos, which is kind of add-on that you can do more advanced stuff. And then this is the graph builder. It's kind of nice. You can select your graph, drag it up here, and then you actually like drag your variables in. There's other utilities, extensions, and some support documents. So a lot going on here. So what I would suggest SPS for is I would say either very simple or very complex data. SPSS is great for just getting a quick analysis out, or if you want to do something like, for example, Amos does structural equation modeling. It's a great program to use in. If you're already familiar with kind of mid-level statistics and other software, this probably isn't the one for you. But great introduction and great functionality at the higher end. All right, moving on to number 3, Excel. Now, this might have been a surprise, but I'm considering Excel as number 3, and it is a spreadsheet developed by Microsoft in 1987. And this, my friends, in your toolkit, my friends, for you, this is your hammer. It's basic, it's blunt, doesn't do much else other than hammer, but it's good at hammering. Excel is very easy to access because it's typically built into most computers, and there's also, of course, open source versions of spreadsheets like LibreOffice or OpenOffice if you don't want Excel. So pretty basic features. It's an interactive spreadsheet, and it has functions. So you can do things like get averages, and you can also graph things and run other sorts of images. So downsides, now I would not technically call this a statistical software package, even though it can do statistics. So there's that, and of course it's very basic. You really can't do any advanced analysis to these. However, Excel is pretty broad, and there are things like Excel Stat. You can actually add and do statistical research within Excel itself. So if you're an Excel man through and through, and you want to do everything in Excel, there's options. In fact, turns out as I was researching, there's a lot you can do in Excel that I didn't realize. In fact, you can even create beautiful artwork in Excel, like this man in Japan here. Though I think there's pretty strict steep learning curve. So far I'm only at like Super Mario Brothers 1 background level artwork. But that being said, here is an example in Excel. Obviously, the really nice thing about this is you can manipulate your data endlessly. So that's a great starting point. And of course, here's the functionality. So you can do things like averages. There's a lot of mathematical things you can do, a lot of statistical things you can do. And of course, a very handy functionality is inserting different charts. So this is probably the quickest way you can get a rough and ready chart that I know of. So what I would consider Excel to excel in, as it were, is the not so much statistical analysis, but formatting and exploration, kind of the first steps. Be able to format it and explore it. Maybe look at mean, median, mode, look at simple graphs, things like that of that nature. Excel works very well for that. All right, galloping along now to number 2, SAS. SAS, in addition to being one of the most fun statistical softwares to use in puns, is also a multi-purpose package developed by SAS Institute in 1976. So it's one of the oldest ones we're considering here, so has the largest legacy. I would consider this to be your table saw. It's big, it has a lot of nice right angles, and it's powerful, and it can get through a lot, though it's kind of bulky. So you can get a free version of SAS through SAS Studio. You can follow this link here for that. It is like cloud-based, so you need internet connection and run it through your browser, but it is pretty nice. So this is what it looks like when you have it and you need to sign in. It comes to this dashboard, and then you can use the SAS Studio, and this is what it looks like. So there's a lot going for SAS. I'll just kind of walk us through here. Since it's the oldest and it's kind of proprietary software, it has a very consistent structure, has a lot of directories, has a lot of sample data, so a lot for you to work with here. And so here's the different directories. You can set things up for classes, so everyone in your class can like access data. That's what I've seen work. And here's your different data sets you can load in. So you can have everything kind of in one place. You can view the data right in here. And then when it's coding. So you would create sheets of code and run it. And if you see here's like results, or like if you want to print stuff like graphs or tables, there's a log telling you what happened. So if something went wrong, you can figure out what went wrong. That's really nice. And then you got your output data. And you can see here there's like different colors for different things. And it's actually anticipatory. So if you like start typing something, it could finish what it thinks it might be. So that's pretty helpful. This is a great place, has good functionality for transforming data from like long to wide. And of course, it has a whole sorts of supporting documents and tutorials. So there's a lot of support for SAS. So now, some downsides. First of all, not everything SAS has available is available in SAS Studio. So if you really want everything, you're going to have to pay for it, unfortunately. But you can do a whole lot just with Studio. And there are also some upload limits. There's only so big of data sets you can upload into SAS. So if you're working with large data, that can be a problem. I've actually had to like split my data up piecewise and put it back together in SAS for some data I needed to do in SAS, but I only had Studio. So that was a big pain, though for most smaller data, it does just fine. And of course, another big downside, if you're not familiar with coding, you notice here, this is all coding. So you have to learn SAS nomenclature and how to run things with code. That being said, it's pretty consistent coding structure, unlike some other programs. So once you get it down, it's pretty straightforward. You do a proc function, data function, things like that. It's gets to be pretty straightforward. And once again, it's anticipatory, it's colored, so it's pretty easy to get nice structured code. All right, so I would suggest using this for pretty much all-purpose data. I use SAS a lot for standard procedures in my analyses. All right, before we get to the number one toolkit, I would like to bring up some honorable mentions. First of all, there's Minitab, which is another proprietary software available through Citrix. I think it's in some ways similar to SPSS. I just really haven't worked with it. I'm sure it's great, but I don't know too much about it. MathWorks and Mathematica are other ones. They're really great. They're a little bit more mathematical,
physics in nature, so if you have that kind of work you need to do, those are great, but they do a lot of statistical ones that are fine. One's just fine. They're just, once again, take some learning and are good for specific purposes you want, not as general purpose. And then finally, Python. Python, I think, is absolutely great, though I don't use it really for statistical analyses. I know it can be used for that. I just don't. I use it mostly for a lot of like parsing data or formatting data, which is a great front step before my analysis. But if you know Python better than me, I'm sure you know just what sort of functionality you can do with statistics as well. So, drum roll, please. Number 1, R. If you're an R fan, you surely knew that this was coming. R is a programming language and software environment developed by the R core team in 1993. And when it comes to tools, this is a Swiss Army knife made of Swiss Army knives. R can pretty much do anything, though it's a bit duct taped together. So you can get R if you want through the Statistics app, or you can just, it's free and open source, so you can just download it yourself. That would be my preference. You can do this through cran.rproject.org. And there's lots of ways to use R. So there's just the basic R show here, which is just pretty much a command line. It's all typing code. You can download something called R Commander, which is a graphical interface, which has much more the drop-down style that you would see in, say, like SPSS, though it does run all the code for it. So this is a good way to like learn some R code if you're a complete beginner, but still need like analyses and graphs. And then my personal favorite, which is R Studio, which is another sort of kind of interface. It's great because it has the command line, but then it has ability to have like scripts, so you can write and save your code right in the whole program, as well as other handy features. And then another big feature of R is it has packages. So there's the base R, which is a lot of different analyses, but then anyone can create and add packages for specific things. And so there are like literally like hundreds and hundreds of packages. I mean, here's the full list here. And as you can see, like we're scrolling down and we're still in the A's, B's. I mean, just it's kind of just ridiculous how many different packages there are for your use. For anyone, anywhere from like I've seen ones that you can like get the palette colors from like the original Pokemon game if you want to like have that for your like graph colors, I guess, all the way to like simulating generalized linear mixed models. So the packages let you have pretty obscene amounts of functionality with analyses. So here is RStudio kind of in all its glory here. Here's you can open files and get data. So this is like my code here. So it's really, really nice. And then you can just like do the command line straight down here if you want, and it'll all just run there. Or with your code, you can highlight and run it, and then it'll pop up the code and run everything from there. It kind of shows you your history, your environment. It's really nice. Any plots will show up right here, and you can go back to like earlier plots. You can see what packages are on. There's actually even like a little help function built in here, so you can like on the fly as you're working, be like, shoot, how does bot plots work? There we go. Okay, that's it. So really great stuff, and I would say the premier way to use it would be RStudio. So some downsides. Obviously, this is all coding. So again, like SAS, this is a real learning curve if you're not used to coding. And unlike SAS, R has no really standardized notation of like making functions or packages. So it can be pretty scattered. And so especially when you have different packages which use different notations, you really have to figure things out more and dig into things more than you would say in SAS. So R definitely has the biggest learning curve to any of the software that we saw today. That being said, once you get over that curve, you can do more things than any other software, I would say. So what I would suggest you use R for is, all-purpose data, and for lack of a better word, for like the weird stuff, like those odd, awkward analyses that you can't figure out how to do anywhere else, you can do in R. I mean, for example, I was having a problem like getting specific like SAS transport files into SAS Studio, because I think they were made just for SAS, the main system, not Studio. So I was really having a hard time getting into Studio. Turns out there's a package in R that I could like open SAS files with. So I used R so I could use SAS. I mean, that's the kind of thing R just is great at. All right, so with that, I'm going to turn over to our next little portion, now that we've walked through our top ones, of showing you an example of data. This is Kokanee fish, and we're going to look at all 5 softwares, how to do a simple regression analysis with this data to see how kind of it fits on each of the softwares. So the fish, almost 300 observations. There's length and weight of salmon, so we're going to compare those two. There's also distinctions of male and female, but we won't actually use that. Let's start our example out in Stata. I've already imported my data set on the Kokanee salmon. So I'll next do some quick summary statistics. And we can add any number of variables. So we're going to do length and weight because those are the two we're interested in. For our regression, we're going to see if we can use length to predict weight. So there we go, some quick summary statistics. Let's also do some histograms. So histogram up here. Let's start with length. It's not terribly important how it's distributed for length because that's our x variable, but it's still good to take a quick look at. Okay, so pretty even except for the right end here is extended. Now we see that the code for this is actually just histogram variable, so I'm going to use the command line for this next one. We'll do this for weight, and boom, it pops up. So it doesn't look terribly normally distributed. We don't have that symmetry we'd hope for, so we're going to do some data transformations. So we'll go over to data editor, and let's start by creating a variable. Let's call it natural log of length, and we're going to create a natural log variable. So you can actually go in here and build things. So for example, if we want math, it's all sorts of functions, and we want log, which is the natural log. So OK here. Actually, I didn't do it, but we can just type it in. And then we'll do our variable of length. We'll go OK. And boom, it pops up. That looks about right. Natural log of 42.4 is a little over 3. So let's do that again. But instead, length, let's do weight. Natural log of weight. And there we go. So now let's histogram. Okay, that one looks better. That looks better as well. Not perfect, but I think good enough for us to go with a like regular regression. So let's start with just all we're going to really do here is want linear model, linear regression, which is very basic. We'll start. Let's do, so weight is going to be our dependent variable or our y variable, and length will be our x variable. And there's different settings, but I don't think we need anything different than just the standard. And we ran here, and these are our outcomes. So some of the important parts here, it looks like length, that was significant in our model. Looks like it was positive. And taking a also look at the overall model, again, it's positive, it's significant. R squared is almost 1, which means almost all of our variability in weight we explained by length. So great. Let's do one other thing. Let's take a look at our residuals. So residuals versus fit, that tells us how well our model fit. I think we can just, you can add other stuff, but if you just do OK, it should plot the residuals we just got from this model here. And here we go. And so you see here, they're nice, kind of even. They're not like a shotgun blast. That's good. They're a little loaded on this end, but I think that's good enough for us to conclude that our model fit well enough. And then finally, let's plot our results. So if we just do a two-way graph, a scatter plot, where we go, we want to create one. If we just do basic, so we want weight, length. Okay, that's what that looks like. But if we want our best fit line, I'm actually going to do it in command line. So the normal graph for a scatter is two-way. I'm going to add this special LFITCI. That is going to add our best fit line from our regression. And then we'll just do a scatter. That'll give us our dots. Sure everything's spelled correctly. And there we go. We've got our, as the natural log of length goes up, so does weight. And it's a pretty tight fit, unsurprisingly. Okay, so that is how we do that in Stata. Now I have switched over to our next software, SPSS. Again, I have already imported my data set here, and then I have my output screen to the right here. So let's take a look here. Let's do some descriptive, let's see, yeah, some descriptives. Let's do both length and weight at the same time. That pops up here, very similar to how we did our other one. Now, we know we're going to want to transform our data, so let's go to transform, and I believe we just need to compute variables. Yes. So, target variable. Let's see here. We're going to call it natural log of length again. And we can use, let's see, arithmetic, natural log. Looks like we just need to do natural log. Actually, we couldn't just pop it in there. Great. Okay, and let's do another transform. But instead, we'll call it weight instead of length. We will pop our weight in right there. Great. So now if we want to do some histograms, let's just knock these out. Here's our histogram. We drag it up here. And let's do natural log of length. So you're going to want that on the x-axis. It's going to build it. And here we go. Very similar. We see that it has that trailing end, even log transformed. And let's do another graph. But this time we'll use our weight here. There we go. That's how to do that there. Next, let's before we actually do a regression, let's do one more graph. It's probably better to do this right away. Let's do a scatter, just so we can get a feel for what our weight and our length should be. There's that. Okay, here we go. And so even before regression, we can see, yeah, I bet they're really closely related. Okay, now let's analyze. We can do just a regression, do a linear regression. So our dependent is our weight, independent is our length. We don't have any selection case variables, so we can just go from there. So it runs through here. The take home with like the model summary, R squared, very high. Our length, that was significant. So again, we see that the two are very significantly related. And an easy way with the regression you can actually choose this one. It actually includes a fit line and everything, so you don't have to do anything else. So that's, yeah, it's great. And it shows the R squared linear. So this is a very good fit. All right, that's all we needed for SPSS. Onwards to Excel, where I have my data set right in here. And so before we get started, let's just create a new couple variables because we know we want to transform. So boom, it's great. And then we'll use the function. So you can either grab function from here, and let's use statistical. No, it's probably going to be mathematical. Let's see, natural log. There we go. Natural log, and then we're going to do of length. There's that. If you want to prompt the function, you can just do an equal sign, and then you can type it out. It's predictive, and then we will do that. And then a handy little thing, if you want to copy the same function across multiple cells, you can just hold down, and then that will do that for all these entries. Boom. That's great. Okay, so let's see here. Let's do some. I'm just gonna do a couple here of summary statistics. Let's see, mean and median. Let's just do median. I mean, we can do more, but mean. No, I think it's actually called average. There we go. And we're going to do length. that, and we'll do that again. See, this is a little more cumbersome to do it one at a time than those other software, but it's not too hard. And then like median, just median. Great. Median. You get the point. You can use standard deviation. You can know min, max, I think even quartiles. So anything you want to do here takes a little work, but perfectly serviceable to do so. Next, let's do a couple plots. So we can go to insert. So let's do like, let's do histogram. And oof, okay, we got a histogram. It's pretty messy. So, but there it is. So I'd probably suggest maybe not doing histograms in Excel, or maybe you'll need to play around with a lot more of the details to make them a little nicer and more informative, because this is kind of messy. But there you are. And if we want to do a scatter plot, let's first move these around, just because scatter plots are charts in here are kind of finicky, but here we go. And there it is. And if you notice, it's quite a bit different from the other ones, because it didn't automatically like scale our axes. It goes, this starts at 0, where the other ones like were like at 4 and like 3. But we'll fix that. In a second here. So it's really hard to do much with the base package, but there is, however, a add-on you can do. It's called data analysis, and it has some of the basic things like ANOVA and regression. So let's just try this out here. So Y range is going to be, wait, and then X range. Oops, I think let's see. Let's try that again. Let's see. Excel is definitely a blunt tool, but the big benefit, of course, is being able to really manipulate your data in real time and see it the whole time. Okay, I think we'll just run that. Okay, and look, gives us a whole new sheet, and pretty straightforward. You know, same sort of R squared, same sort of significance, that it's highly significant. So great. And if we want to do things from our plot to add a best fit line, let's go to chart design. We can actually do a quick layout. I always like to do layouts that have actually the linear data. So here's the equation. So we get the best fit line and everything. And now let's change our axes. So let's instead of starting at a minimum, let's do like 2.5. Okay, that looks good. And from this axis, and looks like we can go all the way up to 4. And there we go. A pretty serviceable plot that looks a lot like those outputs of the other software. All from the comfort and ease of Excel. We've made it now to SAS. And of course, the nice thing about SAS is I have my script already written up and we can run it. So first of all, import and then print our data set. So here's our data, that looks good. let's set our data and then run proc univariate on everything. Proc univariate will give us our summary statistics, and then we also can do histogram right in there with a normal distribution sort of overlaid. So it gives a whole bunch of stuff on each variable. That's length. We'll skip the non-transformed one. Get to like the natural log of length here. Get our mean, standard deviation, and so forth. And here is our distribution. Here's like kind of the normal. So you can see it's not perfect, but I'll get over to weight. Not the best, but I think close enough. Normality is sort of an approximation, really, anyways. If you get close, it usually works pretty well. So let's just do a quick plot also of scatter plot. Great. Once again, see the axes are formatted, so it starts at 3 and then like 4 something. And then we're going to use proc glimix. So this is generalized linear mixed model. But it can do anything lower, like a very basic regression. So I usually use glimix for anything regression, kind of a one-stop shop. And I'm going to put plots on here, so we'll get residual plots, kind of like we did in Stata. Our model is going to be weight and length, and then we're going to output our predicted variables. And we'll see what those look like. So here's our data. So length was significant. And here's our residuals. So for example, this was that residual and predictor plot. And once again, it looks good enough for our purposes. Here's our actual residuals, our predicted variables. So, and then lower and upper confidence limits. And we're going to actually use this information as well as this other information that we already had to produce a nice plot. So we're going to use this proc SG plot. We'll get a band for our confidence intervals, a scatter plot for our raw values, and then a series plot to give our line of best fit. So if we put all those things together, bada bing, bada boom. There we go. At last, we're within striking distance of the end. I have my R data in our studio here. So here's my nice code I have already. So let's get our data in. All nice like. Here's all our fish. We printed out. Again, we'll transform our data, and then we're going to do a summary of them. So this gives our summary statistics. And nice lines here. We'll do histograms, and because I like to color code mine, I will do those here. So we got weight. And if we go back on our little plots, we can get our previous plot of length. So there we go. And if we want to do a nice little scatter plot, we can run just that, and it shows up here. So then we're going to create a linear model and save it. So linear model, weight, length. Let's do that. It's not going to do anything because we saved it, but then we'll do a summary of it, which will show us all our nice deets. And again, like this, very significant. Multiple R squared shows us, predicts quite a bit. And if we do plot, distributing up, it'll do our residual plots. You have to hit return. So here's a residual versus fitted, not bad. Normal QQ, scale location, residual versus leverage. Those ones tell you other things too. I usually just look at the first one or two. And finally, we're going to plot our thing again, and then we're going to add a line from our linear model, which is going to give us our best fit line. And that's all there is to it. So with that, I will summarize and close. Thank you for joining us today. Hope this was informative. I have provided a summary handout as a link. And this is kind of what it looks like here. It has some general information we went over, resources, and then as well as sort of bare bones schematic examples of doing kind of standard tests or graphs in each of the 5 softwares. So there should be a link underneath this video if you went through DaCCoTA. If you're coming through the YouTube channel, you can go to our resources page under special topics talks, and then the Statistical Software Toolkit. There should be a summary handout link, as well as links to these slides as well. Thank you and have a great day.